Hi, my name is Stefan Toetzke. I'm a lecturer for the German derivative exchange, Eurex, and I'm teaching the members of the Eurex exchange and their buy-side in options and futures. In my classes, I'm using OptionScape, and I would like to introduce you into this software. Let us start building a strategy. Building a strategy starts with the strategy builder. I have here already a butterfly, but I would like to show you how to implement your own strategy. So we go to this symbol, new strategy. We have to give the strategy a name, long call. From the demo data set here, we choose the Standard & Poor's options. And now the demo set data are downloaded. The spot price of the Standard & Poor's is actually 1989.3, and I would like to buy a call slightly out of the money. So I go to the strike of 2100, right click, and then I see the futures, the calls, and a little bit lower the puts. I go for the 18th of December call and buy it for 27.4. That's my long call. Here I have the portfolio, which includes actually only one long call. What I now would like to do is changing market scenarios. If I do nothing, the price of the underlying stays the same. I would like to simulate the crash at the beginning of September. Here's the 5th of September, so market should have a sharp crash. And then have a recovery. So the low is here at the 6th of September, so the implied vola should be also on the 6th of September very high. And then going down. I can use this for a lot of different stress scenarios in the simulation. There are also interest rate scenarios, margin multiplier, which is assuming that the clearinghouse will multiply the standard margin in a crash scenario. I go to payout, and now I can calculate the payout of the long call, including my scenario. This is a three-dimensional diagram with different axes. On this axis we have the index. On the backside, which I can change, here is the time axis, and on the y-axis I have the level of the call. I can rotate to have a better view on it, and then we can see here that we have a cross. I go here, and the value of the cross is given here on the upper side. It's the date, the market, and the payout. In other diagrams you have then here the delta or the vega or the other variables. We see that on the day of expiration the call has only intrinsic value or 0. This is this area here. And at the beginning, before the crash, the call has a specific value. Then when the volatility kicks in hugely, we see there's an explosion in the value of the call, and the call becomes devaluated because of the fall in index, but at the same time it's rising because of the increase in volatility. Another nice tool, not for the long call, but for other strategies, is the margining. Because in the long call we have paid already the maximum loss. There's only a flat area, but when you have net short positions, it shows you nicely what will be the margin calculation. You see in addition this area which shows you by a given confidence level the area where there's the highest probability that the price will be in. We go now to the delta, and here also I would like to see the beginning of the delta in the beginning of September, and you see this is a standard delta wave, but when the crash comes in, the Gaussian bell widens the area of possible prices, so we do not reach inside of the given area, of the given range, a delta of 0 or a delta of 1. This is further out of the range. But with lifetime going down to 0, the delta becomes more and more extreme. The Gaussian bell becomes smaller and smaller, and at the end we have a binary delta of 0 out of the money and 1 in the money. Again, you see here the confidence level in which area mostly the price will be with a given probability. And you see the black line which shows my given scenario. We are starting at 1,989, then we go down nearly to 1,000, and then the price in my given scenario goes up to where it comes from. Here we have the gamma. Also the gamma looks at the beginning more or less normal, but then when the volatility rises, the Gaussian bell widens and brings down the gamma near to 0 or to 0, because per unit with this high range of possible prices, the gamma has to be very small because the delta change is so small. When we go to the day of expiration, we have an at-the-money explosion of gamma, and here we see the details given at the point of the crossing, which is in this case here at the money near lifetime. So theta looks nearly the same. We go on the opposite side, and we have an explosion in negative theta on the day of expiration in the last week at the money. And Vega is different because Vega has the highest level at the money long time. So at the beginning of August and beginning of September, here at the money we have the highest values. Then we have an explosion in volatility, which widens the Gaussian bell so that we have a huge increase in out of the money and in the money Vegas, which is diminishing to the time of expiration. So we still have at the money the highest Vega, but it goes down to 0. Yeah, this gives you a short idea about what you can do in simulation and stress testing. I use it in the classes directly after explaining theoretically what are the Greeks, and then making assumptions and estimations about the Greeks with different strategies, and then evaluating it, how it looks like in the modeling of OptionScape. And then we can discuss why does it look differently from what we expected, and analyzing different strategies with different stress scenarios. This is a lot of fun also when you are going real-time live into the market with a class, analyzing technically the market and the volatility, and trying to figure out what would be the best strategy under the given scenarios and assumptions. And yeah, and it helps you really to get a much clearer look into your more complicated strategies. I hope this has helped you a little bit, and you will use OptionScape. And yeah, thank you for looking this clip. Bye.